Hello dear students, how are you? I am Vivek Sharma, your mathematics teacher. I teach class 10th in your school. In this video lecture, here we will represent the situations into the form of quadratic equations. In this video lecture, here we will solve the word problems of exercise 4.1. Before starting this, please like, share and subscribe my YouTube channel. Exercise 4.1. Represent the following situations in the form of quadratic equations. Here in this question we have to convert the given situations in the form of quadratic equations. So first part, the area of a rectangular plot is 528 meters square. The length of the plot is one more than twice its breadth. We need to find the length and breadth of the plot. As the plot is of shape rectangle, so here in the rectangle we know that there is a length and breadth. So here first of all we consider that the breadth of rectangular plot is equal to x meter. Now in the question it is given that the length of the plot is one more than twice its breadth. So we write such condition as length of rectangular plot is equal to twice of breadth plus 1, because in the question it is given that the length of plot is 1 more than twice its breadth. So we write as twice of breadth plus 1. Algebraically we can write as length of rectangular plot is equal to 2x plus 1, because we have considered that the breadth of rectangular plot is equal to x meter. So here we get that the length of rectangular plot is equal to 2x plus 1. Now as we know that the area of rectangular plot is equal to length into breadth, we know it. Now in the question it is given that the area of rectangular plot is 528 meters square. So according to question, area of rectangular plot is equal to 528 meters square. So as we know that the area of rectangular plot is equal to length into breadth, so we write as length multiply breadth is equal to 528 meters square. The length as we have found above that the length of rectangular plot is 2x plus 1, so here we write the value of length is 2x plus 1, and we have considered the breadth of rectangular plot is x, so we write x, and the whole equation is equal to 528 meter square. Now on solving, here we get 2x square plus x minus 528 equals to 0, which is the required quadratic equation. So here we have transformed the above situations in the form of quadratic equations. To find the length and breadth of a rectangular plot, our quadratic equation is 2x square plus x minus 528 equals to 0. We can solve this equation by middle term splitting method, as you have studied in your previous classes. So we split plus x as 2x square plus 33x minus 32x minus 528 equals to 0. Here I have explained how to split the middle term x. Now let us come the point. So on splitting the middle term, again I am repeating, 2x square plus 33x minus 32x minus 528 equals to 0. Here we take common factors. So after all, here we get 2x plus 33 multiply x minus 16 equals to 0. We can write this as either 2x plus 33 equals to 0 or x minus 16 equals to 0. On solving, here we get x equals to minus 33 upon 2 or x equals to 16. Here we cannot take the negative values of x because our length and breadth cannot be negative. So here we take x equals to 16. So breadth of rectangular plot is equal to 16 meter, and length of rectangular plot is equal to 2x plus 1. We put the value of x here, so we get the value is equal to 33 meter. Let us come on fourth part. A train travels a distance of 480 km at a uniform speed. If the speed had been 8 km per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. First of all, here we need to understand the meaning of uniform speed. Uniform speed means when an object or any body goes with the same speed, there is no change in the speed of an object with respect to time. So here we say that object has uniform speed. So the uniform speed of train is equal to x km per hour. Here we consider it. Now here, as distance covered by train is equal to 480 kilometer. It is given in the question. Now here speed is given, distance is given. So here we have to find the time. How much time had been taken by the train to cover the distance of 480 kilometers. So here time is equal to distance upon speed. So here we use that concept. So time taken by train to travel a distance of 480 km with a speed of x km per hour. We denote it by t1. So is equal to 480 upon x r. Now in second condition it is given that if the speed of train had been 8 km per hour less, means when the speed of the train is decreased by 8 km per hour, so new speed of the train is equal to x minus 8 km per hour, because the speed has been decreased. So the new speed of the train is equal to x minus 8 km per hour. So in that case we have to find the time, because in that case we have to find the time. Why? Because the train is covering the same distance of 480 km with the speed of x minus 8 km per hour. So the time taken by train to travel a distance of 480 km with a new speed of x minus 8 km per hour, we denote it by t2 is equal to 480 upon x minus 8 r. According to question, it is given that in the question train would have taken 3 hours more to cover the same distance when its speed was decreased by 8 km per hour. It means that when the speed of the train was decreased by 8 km per hour, so train would have taken 3 hours more to cover the same distance of 480 km. So in that case, we represent such situation as T2 equal to T1 plus 3. T2 is the time taken by the train when the speed of a train is decreased by 8 km per hour to cover the same distance of 480 km. And T1 is the time taken by the train to cover the distance of 480 km with uniform speed when the speed is not decreased. So in that case, train would take 3 hours more to cover the same distance. So here algebraically we represent as 480 upon x minus 8 equal to 480 upon x plus 3. Finally, on solving we get 480 as a common factor. We get the equation 480 multiply bracket 1 upon x minus 8 minus 1 upon x bracket equals to 3. And finally, on solving and taking LCM, we get 480 bracket x minus x plus 8 upon x minus 8 into x bracket equals to 3. On solving the previous equation, we get 480 multiply 8 upon x minus 8 into x bracket close equals to 3. Finally, on cross multiplication and solving, here we get the equation 3x square minus 24x minus 3840 equals to 0. Now here 3 is the common factor in whole equation. So on taking 3 as a common factor, so finally we get the equation is x square minus 8x minus 1280 equals to 0, which is the required quadratic equation. Now here the next step is to find the speed of the train. Our quadratic equation is x square minus 8x minus 1280 equals to 0. So on applying the middle term splitting method, here we get x square minus 40x plus 32x minus 1280 equals to 0, because you have studied such method in your previous classes also. So finally we get with the common factor as x plus 32 into x minus 40 equals to 0. So here finally we get the values of x equals to minus 32 or x equals to 40. Here we cannot take the negative value of x because speed cannot be negative. So the uniform speed of the train is equal to 40 km per hour. Let us do some extra questions. Question number first. The sum of a number and its reciprocal is 17 upon 4. Here we need to find the numbers. Solution. Here first of all we consider the number is equal to x and its reciprocal is equal to 1 upon x. Now as we have considered that the number is equal to x and its reciprocal is 1 upon x, in the question it is given that the sum of a number and its reciprocal is 17 upon 4. So according question, sum of number and its reciprocal is 17 upon 4. So we write the number is x plus its reciprocal is 1 upon x. Both sum is equal to 17 upon 4. Now on taking LCM we get x square plus 1 upon x equals to 17 upon 4. On cross multiplication and solving we get a equation 4x square minus 17x plus 4 equals to 0, which is the required quadratic equation. Here to find the numbers, please do yourself. Try the middle term splitting method for getting the numbers. Let us come on question number 2. Arun's mother is 26 years older than him. The product of their age is 3 years from now will be 360. We would like to find Arun's present age. First of all, here we consider the present age of Arun is equal to x years, as his mother is 26 years older than him. So we will add these 26 years in the present age of Arun and we will get the present age of mother. So Arun's mother is x plus 26 years, which is the present age of Arun's mother. Now let us come on another condition. 3 years from now. In the question it is given that the product of their age is 3 years from now will be 360. So means 3 years from now means after 3 years the age of Arun will be x plus 3 years. We will add these 3 years in the present age of Arun. So we will get the age of Arun is equal to x plus 3 years. Similarly, we will add these 3 years in the present age of Arun's mother. So age of Arun's mother is equal to x plus 26 plus 3 equal to x plus 29 years. Now in the question it is given that the product of their ages 3 years from now will be 360. So according to question, the product of their ages, it's the age of Arun multiply age of mothers after 3 years or from 3 years is equal to 360. We get algebraically equation is x plus 3 multiply x plus 29 equals to 360. On solving, here we get a quadratic equation which is equal to x square plus 32x minus 273 equal to 0, which is the required quadratic equation. Now to find the present age, you can use the middle term splitting method to find the present age of Arun. Here in this slide, some practice questions is given. Please solve these questions for the better understanding of the concept that how to represent the following situations in the form of quadratic equations. If you do these questions at your home, so I hope you will understand that concept how to represent the situations in the form of quadratic equations. Please do more practice and hard work at your home. Okay.